Hello team, how is everyone doing? Welcome to my completely unnecessary adventure of getting two Titan Zs running in quad SLI. If you're just here for the benchmarks, feel free to skip ahead to the timestamp on the screen or use the chapter selection. For everyone else, strap in. This whole thing started after my first Titan Z video. At the time, I already had two of them because I thought one was broken. Turns out, it wasn't. The drivers were just being Nvidia certified garbage. But hey, now I have two Titan Zs, and if you ever made a bad financial or technical decision, you already know what comes next. That's right, quad SLI. But before we get too deep into this, if you want a more detailed look at the Titan Z itself, how it works and the specs and just everything else, I already have a full video on that, and I'll leave it linked in the description if you want to go check it out. For everyone else, strap in. This gets stupid. Anyway, this all started on X99 with an i7 5820K. Quick problem, not enough PCIe lanes, so I upgraded. 6800K, Rampage 5 Extreme, I felt super smart, but still not enough PCIe lanes. At this point, I'm basically upgrading in circles. Eventually, I grabbed a Xeon, an E5 2604 V4. Plenty of lanes, everything hooked up, quad SLI is finally working. I feel like a genius at this point. Then I launch a game. And the CPU, it's just so slow and it bottlenecks everything into just terrible performance. So now I have a system that technically works, but it performs like a laptop from like 2012. Just perfect. And that was it for a couple of months. I just totally lost my motivation to get this video finished. Then one day, I'm sitting at home, eating Doritos, drinking Mountain Dew, making great life choices. And then I look over at the GPU on my shelf, and I think, I've already come this far. I might as well finish ruining my electricity bill. This time, I went all in. I got an Asus Rampage 6 Extreme Omega, an i9 10920X, 32 gigs of DDR4, which is like $1 million today, and of course, two Titan Zs. Let's just talk about cost for a second. Back when this hardware was new, this was an insanely expensive system. Each Titan Z cost about $3,000. So the complete system, like 8,000 or 9,000. That's like used car territory. And today, we are going to watch it lose to a mid-range GPU. Yes, you heard me right. To make things more interesting, I'm comparing all of this against a single Intel Arc A770. My goal today is simple. I just want the Titan Z to just win in a single test that I'm running. Just one. That's all I'm asking. First up, we have Dirt Rally 2. This one sits right between the release windows of both these GPUs, so it should be a fair fight. But there's a problem. No official SLI support. I had to dive into the Nvidia profile inspector and basically force it using an older profile. And honestly, this is already where things start to feel a bit cursed. It wasn't perfect, and there were occasional inconsistencies, but it did use multiple GPUs. The result? 58 FPS average. And you know what? That almost felt like a win. For something this janky, getting close to 60 FPS isn't bad at all. Then I tested the A770. 134 FPS. No tweaking, no hacks, just launch the game and go. And that's when it really hits you. This isn't just a loss, it's a completely different level of experience. Next up is Counter-Strike 2. Now this one actually surprised me. CS2 is a modern game, not really built with any multi-GPU setups in mind, and it ran on one GPU, so expectations were pretty low. But it actually held up quite decently here, 105 FPS average. It's not amazing, but it's absolutely playable. You could genuinely jump into matches like this and not feel completely handicapped. What is interesting is that this is one of the few cases where the system feels somewhat normal. But then again, the A770 comes in at 192 FPS. So while the Titan Z setup works, the experience still isn't close to what a single modern GPU can deliver. BeamNG Drive. This one was kinda rough, and honestly, it was expected. This game has evolved a lot over the years, and the physics are heavier, the engine is more demanding, and it really leans on modern hardware and APIs. Quad SLI or regular SLI just doesn't fit into that world anymore. 37 FPS average, and it really felt like 37 FPS. Stutters, inconsistency, just not a great experience overall. Meanwhile, the A770 hits 81 FPS, more than double the performance, and more importantly, it's smooth. This is one of those moments where raw GPU power just doesn't matter anymore. Architecture and software support just completely take over. The Witcher 3. Please note that this is the classic version, and this is actually where things start to look a bit more respectable again. 85 FPS on average on the Titan Z setup, and to be fair, it actually feels good to play. Smooth enough, visually great, and you could absolutely enjoy the game like this today. But then you look at the power draw, around 950 watts for 85 FPS. That is insane. And then the A770 comes in with 148 FPS, just sipping a fraction of the power. So yeah, the old setup can still deliver, but the efficiency gap is just brutal. Forza Horizon 4. This one honestly felt just a little bit like a wasted opportunity. It's a game that looks like it should scale well with multiple GPUs, it has a big open world, high visual fidelity, it just makes sense. But there is zero SLI support, which means only one GPU was doing anything. 48 FPS average, and you can feel that something is off, knowing that there's 3 more GPUs just sitting there doing absolutely nothing. Meanwhile, the A770 delivers 121 FPS, just with no effort at all. And this test really highlights the biggest issue with multi-GPU setups. When support isn't there, your insane hardware just becomes completely irrelevant. Final test, Rise of the Tomb Raider. This is the redemption arc. If there is one game that represents what SLI should have been, it's this. And scaling here is actually incredible, 162 FPS on the Titan Z setup. And for the first time in this entire video, everything just worked. No hacks, no weird behavior, just pure performance. And honestly, it feels amazing to watch. This is what people imagined when they invested into multi-GPU setups back in the day. The A770 still puts up a strong 135 FPS, but this time, it's not enough. And I'm not even mad about it, because this isn't just a win. It's a proof that the concept did work when developers actually supported it. So, what can we learn from these results? Quad SLI just demonstrate how powerful multi-GPU setups could be when properly supported. In the right scenario, the performance is still impressive, even today. However, outside of those ideal conditions, the limitations are clear. Lack of support in modern games, inconsistent scaling, and heavy reliance on drivers and profiles, not to mention the extremely high power consumption. At the same time, the Intel Arc A770 shows just how far single GPU performance has come. It delivers consistent results across all titles, without requiring any additional configuration. In the end, this isn't just a comparison between old and new hardware, it's a reflection of why the industry moved away from multi-GPU solutions. Not because they didn't work, but because they required perfect conditions to do so. That said, when everything does line up, Quad SLI manages to deliver a result that just makes the whole project feel worth it. Thank you all for watching this extremely stupid adventure. I hope you liked it. Leave a like or leave a subscription, whatever that means, if you feel like it. And I'll see you all in Q7 2028. Have a good one.